Welcome back to Learning with Merit. Today we're going to take a look at Python characters and strings. In this file we're going to look at characters and we're going to define what they are. We're going to take a look at some special characters in Python. We're going to look at how to convert those characters into different values. We're going to look at what strings are. We're going to look at how to concatenate and duplicate those strings. We're going to look at how to compare string values. We're going to look at how to index strings and what indexes are. We're going to look at how to create substrings or slice up a string. We're going to look at built-in string function calls or functions that go well with strings. And we're going to look at some string method calls that we can use as well. Let's take a look at characters. So characters are a basic unit of information that represents any letter, number, symbol, or even a control code in Python and in programming languages in general. So here we have an example of a character. This character equals is just assigning the variable character to the value of a, and you'll notice that I've put a in quotes here. Now a character is just a single length string, so a single character string in Python. Even a space like this is a character. And then, of course, we have some of those special symbols that we can look at. Now, this is definitely not an exhaustive list, just a few examples of characters. To see a more exhaustive list, let's take a look at this table here. Now, I created this table because this is based on the ASCII table, or the American Standard Code for Information Interchange, and this is built into what we call UTF-8. Or Unicode transformation format, and this has to do with how we store characters as binary values. And there is a lot else that goes into it, including other ways in which we represent that data. So here we have the character column, which is going to show us the character. Here is the decimal representation, the decimal representation in this next column, the hexadecimal representation, the binary, and then finally the octal representation in this column all the way to the right. And I chose to put octal in the right because it seems to be the one that comes up the least. Remember, this is right here is the space character. I know you can't see because it's a space character, but even it has a value. There are numbers that come before this that are not what we typically think of as characters, so we're going to omit those for now. But we'll just scroll down through this so that you can get a good look and see all of the different characters and what their values are. And of course, you can look up ASCII tables online anywhere you want to, and you'll be able to see these different values for these different characters. And pay attention here as we're scrolling. You may have noticed all of the uppercase characters have a separate value from the lowercase characters, and that's because the computer needs separate binary values to represent those as data in the computer. And then the last thing here, if you want a little function, I wrote a little function that you can copy if you'd like. And of course, all of this right here is just explaining what it does. It looks up the Unicode information for a given character based on some code that I wrote. And if you want to, you can have it print the table. It returns a tuple containing the Unicode information for that character. So it'll give you the Unicode code point. It'll give you the decimal, the hexadecimal, the binary, and the octal as a tuple when it returns. So anyway, you could copy down this code right here, and it should work for you. In Python, like all programming languages, sometimes we need special characters. And usually the first special character that we need is something called an escape character. So let's take a look. We use the backslash as an escape character. Now what this does is escaping a character refers to the use of special sequences or combinations of characters to represent characters that are difficult or impossible to represent directly. This is typically used for things like the characters we use in the syntax of Python. So some characters like parentheses or quotes we have to use as syntax symbols, and it's going to make that difficult for us to represent them in strings of text, for example. So let's take a look at some of those. The new line character, which we need in order to represent a new line whenever we're printing something out to either a file or to the standard output. Here we have first line, \n, second line. And when we print that out, it looks like this. So first line, and then we move to the next line, and we print second line. Notice that you don't actually see \n anywhere. You just see first line, then we move to the next line, second line. \n will come up quite a bit in programming, by the way. There are lots of times in which you want to format the text that way. Then we have \t. This is the tab character. And tab characters are different than spaces, although typically tabs are somewhere around 4 spaces. If we print this out, what we see is we get some spacing. And the spacing is, at least in this case, a little bit inconsistent. So you need to be careful about how you use tabs, because tabs can really mess up your Python if you're not careful. But this is how we would represent those tab characters in Python. Then if we need a single backslash character, we're going to have to escape the backslash with another backslash, because our escape character is the backslash character. So in order to actually use it in our program, we're going to have to make sure that we use double backslash. So if I print out this path right here, and this is a Windows path starting from the C drive, the root directory of the C drive, and we look through all of this, this is what it'll actually print out. So single backslashes for that path. And if we didn't do that, we would run into some errors. Next, maybe we have a string that contains a single quote. So we have a single quoted string that requires a single quote inside of it. Well, in order to prevent this from resulting in an error, we're going to use the backslash character right here so that we can add a single quote inside of a single quoted string. Otherwise, what would happen is it would stop right here at it, and we would run into an error for the rest of it. And this is what it prints out. It says it's an escaped character, like that. Then if we have double quotes, we do the same thing. So if we want to put double quotes inside of a double quoted string, we need to use the backslash characters to escape them. And if we print this out, you'll see that instead of just printing out lookout for double, it prints out lookout for double in quotes. So that's different than how print normally works, where it just prints out lookout for double. Whatever's inside of the quotes, it just prints that out without the quotes surrounding it. But if we want quotes to surround it, we add these backslash characters to do that. Then the carriage return character. So for most people who are watching this, you probably never worked on a typewriter, but there was a piece of the typewriter called the carriage, and you needed to return it back to the beginning of the line to continue typing on the typewriter. So this little character is called the carriage return because what it does is it moves the cursor back to the beginning of the line. So if I do print 1, 2, 3, then \r ABC, what happens is it moves my cursor back to the beginning of the line and then overwrites 1, 2, and 3 with ABC. Now we look at the backspace character. The backspace character is going to use \NB, and what this does is it's going to delete the preceding character, or whatever character is right before the \B. So if we look at this and I print ABC \BD, we end up with ABD because it's going to delete the C and replace it with the D. And then finally, perhaps the weirdest one, and the one that's going to cause you a lot of problems in understanding how it works, because it works differently on different computers and does different things, is the form feed character. I want you to know that it exists, but I will tell you for right now, it's a pretty confusing little character to deal with, and we're not going to look at output from it because the output you may see on yours may be different than the output you see on mine. Typically what this is for, though, is to proceed to the next page or form, and it has very specific uses. So these are our special characters in Python. Remember that probably our most common ones are going to be escaping quotes, like double and single quotes, escaping our backslash character, and using the new line character. These are going to come up quite a bit. Let's look at what a string is in Python. So a string is an immutable, meaning it cannot change, sequence of characters. So we take multiple characters, we string them together, and that is why it's called a string. If we need a new string, we must create a new one. You cannot change the old string. That's what immutable means. You cannot change the value of the data. You can create new data and use it and change the variable that stores it to store something else, for example, but you cannot change the string itself. So let's take a look. With these sequences of characters, we could do something like this. We could use double quotes or single quotes to indicate that sequence of characters. We could store strings in a variable like this. So here we have str underscore is equal to this piece of text. Now, for example, I could change what str underscore stores to some new text, but I can't directly change this string. I would have to create a new string and set str underscore to that. These string literals can span multiple lines and automatically include the new line character at the end. Okay, if we need to remove that new line character, we have to use a backslash to remove the automatic new line character. Remember that this does not work on the first line if you start it without some text. So I didn't put any text here and I automatically went to the new line. If I put a backslash there, it will not actually work. So I should leave my text that I want on that line if I want to escape the line there. Although I will say that in general, the whole purpose of this is to have something on multiple lines. So this is what that will print out right there, is line 1, line 2, line 3, all in the same line. Of course, there's a new line character there and a new line character at the end to separate it. Now we need to look at these backslashes. This is the reason why we have line 1 right up against line 2, right up against line 3, is because we have escaped all of those new line characters. So more technically, strings are objects of the string class in Python. Now, we will talk about objects in depth in a different video, but strings, and technically all data in Python, is an object of a particular class. In this case, strings are of the string class, which and basically what classes are is they define what the data is, right? And so if we take a look at this, here we have print, and I am printing the type of this string right here. So here's the string, and I'm getting the type with the type function around it. And then finally on the outside, I'm printing out what that type function returns, right? And it returns class string. So it tells me the data type of whatever I'm looking at in here. So that is how we know that strings are of the class string in Python. String concatenation and duplication. So concatenate means to join. So we're going to join things. And specifically, we're talking about how to join strings. So let's take a look here. String literals that are placed next to each other are automatically concatenated in Python. And here's a great example of why that might be useful, because normally you just put it all in the same string if you're going to do that. This is really useful for breaking up long strings. So if we have a string like this, I can put it in quotes, but I also want it added to this, added to that, added to that, added to that, added to that, right? So this is a long set of strings, but it's very useful for me breaking up this one long string into little pieces that allow me to read it a little bit easier in the text editor. So we don't want to make this one giant line that's really hard to read, so we can break it up like this, and whenever it's used, it's automatically concatenated. We can also join them manually. This is a little more useful whenever we are storing these values as a variable, because normally if I was going to do this with the two literal values, I'd just write one string that's already like I want it. But if I use variables that store hello and world, I can use the plus symbol to concatenate them. Or if I had one that's a variable, I could concatenate it with the other thing. Now what you'll notice is here I added a space. That's very important not to forget that space if you want the output to look like that. Otherwise it will just slam the W and the O right next to each other. Now if we want to duplicate strings in Python, it's very simple. We just use the multiplication operator. So here I have A and I do multiplied by 3. That will give me a string of 3 A's. So this is concatenation and duplication in Python. Now, what if we need to compare strings in Python? And this happens quite often as well. If we take a look at this, we do something called lexicographical comparison. Now, that is a mouthful of a word right there if you really don't understand what it's talking about. But basically what this does is it compares strings character by character based on what we call Unicode values. Now, we've already looked at some of those values when we take a look at like an ASCII table, for example. If we convert those values into decimal, then we can look at the decimal values to compare them as well. So that's what lexicographical comparison is. And this basically allows us to compare characters in an alphabetical way. It's not completely alphabetical because there are plenty of characters that are not alphabet characters, and we can still compare them in this way based on their Unicode values. But most often you will find yourself doing this type of comparison whenever you're trying to do things alphabetically, for example. So let's take a look at it. We're going to compare the first character of each string. If they are equal, meaning they have the same value, then we move to the next character and we look for unequal characters. Then what we're doing, we are going to either find unequal characters or we're going to reach the end of one or both of the strings. So let's take a couple of examples here. So we're going to compare equality with equals equals. So if we look at this, we say, all right, is hello equal to hello? Well, as you can see, they are identical. The uppercase H and the uppercase H is the same, so on and so forth. That will result in a true. If we compare these two values, however, the lowercase h is different than the uppercase h. Therefore, it is false. So this is how we can compare those two strings. Now, we could also do this. So here we have apple as string 1 and banana as string 2. And we can compare those. So if we look at string 1, is it equal to string 2? Well, apple and banana are definitely not identical. So we end up with false. But now we could also check if they're not equal. So we use the not equals operator. And this would result in true because apple and banana are very clearly not the same value. But now things are going to get a little bit weird. How do I use the less than sign with strings? Well, here's how this works. It's going to compare apple and banana. And it's going to go character by character. So think of it like comparing things alphabetically. A comes before B, comes before C, comes before D, so on and so forth, all the way to Z, right? So if I do string 1 is less than string 2, I get true. And this is because apple is lexicographically smaller than banana. What does that mean? Again, I use that big word. If I compare this, I'm going to start at A and I'm going to start at B. And I'm going to compare the two. Is A before B? Well, it is. I can tell you that lowercase a is the decimal value 97 and lowercase b is the decimal value 98. So A is one less than B based on their values. So what we end up with is that string 1 is in fact less than string 2. And this makes sense alphabetically as well. We would put apple before banana if we were doing alphabetical ordering. Now, if I did string 1 is greater than string 2, I would get false. And the reason is because, again, A is 97 and B is 98, meaning that the B is going to be greater. So we get a false value because it is, in this case, it, meaning string 1, is lexicographically smaller. And so we end up with a false value. If we need to compare lengths of values. So if strings have different lengths, but the shorter string is identical to the longer one up to the length of the shorter string, okay, Python considers the shorter string less than the longer one. So let's take a look at this example. We have ABC and ABCD. Which one is less than the other? Well, if we compare this string 3 to string 4 and we say, is string 3 less than string 4? It is, even though the three values to begin with are identical, but ABCD is less than, in length this time, less than ABCD. Sorry, I should have said ABC is less than ABCD. Let's make sure that's clear. So we know that's true because Python treats the shorter string as lexicographically, in this case, smaller than the one with an additional character or more characters. One special little thing I have for you here, this is a function that I wrote to generate a Unicode table. And what it's going to do is it's going to print out the first 1024 Unicode values that we have in a dictionary. It's going to provide the character, then the Unicode representation of that character, then the decimal representation of that character. And of course, you can change the start and the stop values if you'd like to be very specific, or you could just call it without that and it will default to 1 and 1024. So let's take a look at this real quick. I'm going to clear my screen and I'm going to type python tutorial.py because this is where I have the code for that. And you'll see that it prints out all of the characters through 1000 24 for me. And let's scroll way up and find a couple of the values that we are very used to. So here is our first several values, and there is the \t character that we saw, \n, there is \r right there. We've seen those. And then finally, here starting at 32 is where we get to the characters that we know and love, our space, exclamation point, and these are values that you may see in an ASCII table. There are our numeric character symbols, and here we have the uppercase alphabet, and then we have the lowercase alphabet, and then some more crazy symbols there, all the way up to 126th, and then we keep going from there, and we get some crazier characters as we go, but you can see this is what those different characters look like in Unicode. Ooh, there's a cool looking one right there. All right, so indexing strings. So strings are a sequence of characters, right? And if we look at those, and we could also think of it as a list of characters. And that means that strings can be indexed like list, meaning we give a value for each spot inside of the string. So each character receives a value. So it's given an index starting at 0. We're going to start all the way on the left of the string, and that is going to be character 0 in the string. And we don't want to forget about spaces because they also count as characters and therefore also get indexes. So let's take a look at an excellent example. Here is the string programming, and I've spaced it out just a little bit so it's easier for us to see the numbers. If we look at what we call regular indexing, the P is at 0, the R is at 1, the O is at 2, G is at 3, so on and so forth, all the way to the last G, which is at 10. These are the indexes for each of those characters. Now in Python, we also have the optional reverse indexing. Reverse indexing uses negative values and starts at the end of the string. So here we have -1 all the way at the end of the string, and it goes all the way back to the left using negative values, where P is -11. So there are two different indexes depending on which one you want to use, and sometimes one makes more sense than the other. So here is our regular index, and here are our reverse indexes with negative values. Now let's take a look how we might use this. So here I have the variable word that is storing or referencing, pointing to this string literal in memory. And what I'm going to do is I'm going to access a particular character of this string. Now the way that we do that, I'm going to use a print statement here, but it's actually not necessary. It's just so you can see the output. And then what I'm going to do is I'm going to use the variable name, and now I'm going to use square brackets. Inside the square brackets, I'm going to place the index of the character that I want. In this case, the thing at 0. Now the way I tend to say this is I say word at 0. And the reason I do that is it helps me remember that I'm thinking about the word as a whole, and I'm accessing the thing at the 0 spot in Word. So we want to print word at 0. And what we get with that is we get the letter P. Let's look at some other examples. If I do word at 1, I get R. If I do word at 2, I get O. Now if we use negative indexing, this is going to be a little bit different. So if we do word at -1, I get this G all the way over here on the right. If I do word at -2, I get this N right here. If I do word at -3, I get that I. So depending on whether you use positive or negative indexing, you will get a little bit different way of writing it. Now I could have done word at 10, or I could have done word at 9, or word at 8. But the reason why negative indexing might be useful is maybe you don't know exactly how long this particular string is, and you just want whatever the last thing is. So you could do word at -1, and you know that will work. So this is how we index strings in Python. So in Python, in order to create parts of a string, or use parts of a string to grab them from an original string, we use something called string slicing, right? And this is called creating a substring. So what we're going to do here is we are going to slice up the word programming into different parts. And typically what we do is we're going to provide some type of list, in this case a string, and we're going to give it a start index, stop index, and we need to remember that the stop index is not included. So let's take a look at this. So here, if I do print and then I do word at, well, I didn't provide a value, I just did :5. Well, the computer understands, Python understands, I should say the interpreter understands, to start at the beginning and then go to the 4th index, because 5 is not included. So we start at the beginning. Here is P, so 0, 1, 2, 3, and 4, and that gives us Proger. Then if we do another one, so here is where I put a number to begin with, colon, and then nothing at the end. This is going to start at the 4th index and go all the way to the end. So here we are at the 4th index. That is an R, and we are going to go all the way to the end of the string. So we get this ramming part. Then the way we would normally do this, here we have a print statement. Inside of that, we don't have to have the print statement. Remember, this is just for illustration purposes and for printing out. You see what you actually get out. Here I'm going to do word, and I want to get a substring, so I'm going to use the square brackets here, and I'm going to say start at 0 and then go to 7, but remember 7 is not included, so this is going to get me 0 through 6. So this should get me this right here, this piece, 0 through 6, and that's what we see there. Then if we do 3 through 11, so here is 3, and notice there is no 11. Well, since 11 is not included anyway, that just takes us all the way to the end. So 3 through 11 gets me gramming, like that. Then if I do negative indexing, I need to be very careful because I can result in an error by putting a larger negative index in front of our smaller negative index. So for example, if I reverse this, I did -1 and -5 reversed, this would result in an error because the computer can't do that. So what we need to do is -5. So here is -5 through -1. That should give me just like this. Now, the reason it didn't add the G, remember, -1 would not be included. So it's going to give me just this piece right here, MMIN. We need to remember, very important, I've said it several times, I've written it twice, the stop index is not included in the slice. So you need to remember that every time you create these, that the stop index is not included. And one more thing we need to remember is that our Python strings are not changeable. They are immutable, meaning you cannot change their value. You can always create a new string, which is part of the reason we like to do this. String slicing allows us to create a new string with a part of the old string, but we cannot actually change the old one. For example, if I tried to do word at 0 equals capital J, this will result in an error. Let's actually take a look at that. So if I type clear here and I do Python tutorial-py like that, what you'll see is I get this error and it says string object does not support item assignment. That means I cannot do this right here. You'll also notice the other outputs that we got that are the same as what we expected right here. There are a few built-in function calls that are commonly used with strings that are good to know. The first one, and perhaps the most important, is the length function call, so len. This is built in and defined for us, and len is going to give the number of characters in the string, and you need to remember that spaces count as characters. They are characters. So if I do length word, programming has 11 characters in it. Now, if I want to get the last index of word, I would do the length of word -1. This would give me the last index. These two little function calls are extremely important to understand in programming because when we use strings and lists, this comes up all the time. We need to know how long the list is, or how long the string is, and what is the last index. So, because we may need to use that index for something. Now we also have the max value. This returns the maximum character based on the Unicode code point in a string. Remember that R is going to come after. It has a larger value than all of the other characters in programming. And then we also have min, and min is going to return a capital P because it gives us the minimum character based on the Unicode code point. By the way, if you're curious as to why it returns P and not A, it returns capital P because all capital letters are lesser, have a smaller Unicode value than all of the lowercase letters. So even though A, in the rest of the string, A is the smallest character, capital P is smaller because it is a capital letter and it comes before all of those lowercase letters. Anyway, very interesting. You should look up the decimal value of P and the decimal value of lowercase a, and you will see the difference there and why that returns capital P. So those are the three basic function calls that we use a lot with strings that you might want to know. We're going to take a quick look now at the built-in string method calls that there are. And these are going to be similar to functions, but they're a little bit different. We're not going to go in depth with each of these. We're just going to give you a quick introduction to what they are and in general what they're designed to do. So first we need to know what a method is. So methods are basically functions, but they are defined by a class. And they are typically associated with objects or classes, and that's how we're going to call them. So we associate them with an object or a class, and we use this dot syntax here to call them. So we will have an object and then dot method, and then of course we'll have parameters like we do with any function call. If we don't have an object, we would have a class, and the class would start with a capital letter, and it'd be class.method, and then parameters again, and then these are for methods which do not require objects. So since strings are objects of the string or str class in Python, I'm going to create a string. And here we have string, and I just went ahead and named it string as the variable name just to make it very simple so you know what we're dealing with. If you want to know what methods you can call on a particular object, you can use the dir function. So dir and then the object. In this case, we would put string inside there. And then it says to see more information, we could also use help and then object.method if we needed that. All right, so let's go through these different methods. Here we have string.capitalize. This is going to return a copy of the string with the first character capitalized. Then we got string.casefold. This returns a case-folded copy of the string, suitable for case-insensitive comparisons. So if you don't care about the case of the characters, you could use this in order to help compare. String.center is going to return a centered string of a specified width, and there will be a fill character that you could optionally provide that will be used for padding that string. Then string.count is going to return the number of occurrences of a substring in that string. So we're looking for a particular character or a particular set of characters. Then we could use string.count to see how many times that shows up in a string. Then we could use string.encode. This is going to return an encoded version of the string, and there are lots of different encoding types you would have to specify. Typically, it's going to be UTF-8 by default. Otherwise, you would have to specify. Then we have string.endsWith. This is going to check if the string ends with a specified suffix. So we're going to look, does this string end with this sequence of characters? And it will tell you yes or no on that, basically, true or false. Then we have string.expandTab. So if you have tab characters inside of the string, it will convert them into spaces. And you could specify a size on that as well with tab size. All right, next we have .find. So this is going to return the lowest index of a substring in the string. In other words, the first occurrence of the substring inside of a string. Then we have string.format. This is going to format the string based on specific formatting requirements. Then we have .formatMap. This is going to format the string using a mapping. You have to look into what a mapping object is if you want to know how to use the formatMap method. Then we have string.index. This is also going to return the lowest index of a substring in the string. And again, this is sort of the first occurrence of a particular value. Then we have string.isAlnum. This stands for alphanumeric. And what that means is all of the alphabet characters plus the number digits, so 0 through 9. So it checks if all of the characters in the string are alphanumeric characters. Then we have string.isAlpha. This checks if all the characters in a string are just alphabetic characters, so not including numbers. Next we have isASCII. This is going to check if a string contains only ASCII characters, so that should be decimal 1 through decimal 128 approximately, and that is going to be your ASCII characters. So this covers pretty much all of our alphabetic characters and most of our symbols that we see on our keyboard. Then we have is decimal. This is going to check if all the characters in a string are decimal numbers. Then we have is digit. This is going to check if all of the characters in a string are digits. Then we're going to see is identifier. So dot is identifier. This is going to check if a string is a valid identifier. Then we're going to see dot is lower. This is going to check if all characters in a string are lowercase. Then we have is numeric. This is going to check if all characters in the string are numeric. Then we have is printable. This is checks if all the characters in a string are printable characters. Then is space. This checks if all the characters are space characters or white space characters. Is title is going to check if the string is title cased, meaning each word starts with a capital letter. Then we have is upper. This checks if all of the characters are uppercase characters. Then dot join. This is going to join the elements of an iterable to create a string. So for example, if you had a list of characters and you wanted to create a string out of that, you could use string.join. You could also join two strings this way. Then we have string.ljust. This is going to return a left justified string of a specified width with a fill character that's used for padding. So this just means we have the string all the way on the left-hand side, and then we pad to a certain length with extra characters. Then we have string.lower. This is going to return a copy of the string converted to lowercase. Then we have lstrip. This is going to strip out a sequence of characters from the beginning, and basically it's just you're giving it a list of characters basically when you do this, and it will remove any of those characters that happen to be at the beginning of a string. And then we have string.makeTrans. This returns a translation table usable for string.translate. Then we have string.partition. This is going to split the string at the first occurrence of a separator. So you're going to have to tell it a separator that you want to use inside of the parentheses here. And that is going to split the string up at that particular spot. But again, just the first occurrence. And then we have remove prefix. This is going to remove a specified prefix from the string, so the beginning part of the string. And of course, we have to tell it inside the parentheses here what the prefix is we want to remove. Then we have remove suffix. This will remove a sequence from the end of a string. And again, we have to tell it inside the parentheses what suffix we want to remove. Then we have string.replace. This will return a copy of the string with all the occurrences of a particular substring replaced with a different substring. So usually what you'll do is you'll say replace this first thing. So that's why we have old, new, and count. We have old, which is what we are going to replace. New is what we're going to replace it with. And count, if we look over here towards the right, count is optional. It's the number of occurrences that we would replace. So we could limit it to only certain numbers of occurrences. Then we have string.rfind. Now rfind is going to be similar to find, but the difference is it returns the highest index instead of the lowest index. So the last occurrence of a substring. Then we have rindex, basically the same thing. The last occurrence of a substring is going to be returned. Then we have .rjust. This is going to right justify a string of a specified width, and it's going to pad with characters that we give it on the left-hand side. Rpartition is going to split the string at the last occurrence of a separator. So inside there, we have to give it a separator, and it will split the string at the last occurrence of that separator. And then we have rsplit. This is going to split the string into a list starting from the right. And we will typically give it a separator, and then we could also give it a max split, or the maximum number of splits to create using that separator. Then we have split lines. This is going to split a string at line breaks and return a list of those line of those lines. Then we have starts with. This is going to check if a string starts with a specific prefix. We have strip, which returns a copy of the string with the leading and trailing white space removed. Then we have swap case. This is going to return a copy of the string with the uppercase and lowercase letters swapped. So lowercase becomes uppercase, and uppercase becomes lowercase. Now we have .title. This returns a title-cased version of a string. So that means each word basically in the string will be given an uppercase letter to begin with. Then we have string.translate. This returns a copy of the string where each character has been mapped through a given translation table. You'll have to look up those little tables and what they look like to understand how to use string.translate. Then we've got string.upper. This returns a copy of the string converted to uppercase. Then we have string.zfill. This is our last one we're going to look at. And this returns a copy of the string padded with zeros to a specific width. Right? And so what this will do is it will pad with zeros out to a specific, basically, length of the string. Now let's take a look at f-strings, or formatted strings. This was introduced in version 3.6 of Python. And these f-strings provide a convenient way for us to embed expressions inside of string literals. And this is a very powerful tool once you understand the basics of how to use it. So we are going to use the prefix f, or capital F, inside or before our quotation marks, and we are going to use any expressions inside of curly braces inside of the quotation marks. So here we go. Let's take a look. So I've created two variables, a name of Sam and an age of 30, and we're going to insert these variables directly into a string. So we look at our line 402 here, and we have F in front of our string, and this is our whole string right here. And inside of this, it's sort of like a game of Mad Libs, where I've placed blanks where we need a name and an age. And the name and the age in this case, the name and the age in this case is going to be Sam and 30. So the output we get here is, hello, my name is Sam and I am 30 years old. So it directly places these variables right inside of that string. Now we can also do things like format numbers, for example. So here we have a fairly large number. And we might want to separate that number whenever we print it out so it's easier to read. So we could look at two different ways of doing that. Here we've placed the variable n, which stores the number, and then we've added a colon, and then next to that we've used an underscore. So this is going to give us an underscore separated number. And then if we look at this example, it's sort of the same thing, but we use a comma instead. We can also format our floats. So we can do .nf here to round to n decimal places, and we use the f so that we know that we are rounding to certain decimal places. So here we have a number 1234.56789, and if we want to round that to 0 decimal places, we do n colon dot 0f for 0 decimal places, and then we have n colon dot 1f, which gives us 1 decimal place, and then we could also add separators in there to separate out our number, so we can do n colon underscore dot 2f, and it will give underscores where we need them, and it will round to 2 decimal places. And then we could use a comma, and this one's going to round to 3 decimal places. We could also do scientific numbers as well. So here we have a very large number, which is Avogadro's number, and we might want to format that into scientific notation. So here we have F, and in quotes we have our expression in curly braces inside of that. So we have n colon and e indicating that we want to format n as an scientific number. And then we have another example of this where we are now adding the decimal point and limiting it to 3, and also scientific notation. So here we have 6.022 times 10 to the 23rd, which, if you're a chemistry buff, you may know that number as Avogadro's number. We can also format our expressions. So if we take a look here, we have a equals 2 and b equals 3. If I want to print out the expression of what a equals, then I could say a equals, and then I just leave it blank, and what it's going to do is it'll print out a equals 2 if I put this inside of a print statement. And then here we have b equals, and this will do b equals 3. And then I could even do some math with that. I could do a plus b equals, and that would give us a plus b equals 5 whenever it would be printed out. So that will format our expressions inside those curly braces. Then here I have c and d, and of course these are two float values, so 0.1 and 0.2. And if you know anything about floating point arithmetic with programming, this will give us 0.30000, some number of zeros 4, right? And so maybe we want to limit that to just 1 decimal place, and so we do c plus d equals, and then we format the output with a colon, period, 1f. and this will give us C plus D equals 0.3, like that. We could also do C equals 3.141592665. And we can create a variable for the format that we want, and I've called it form in this case. Notice that it is a string. And we could also use it just like this. So C colon and then form. So instead of directly writing .2f here, I can store it as a variable and use that as well. And we should get 3.14 out. Next, we have padding and alignment. So here I have a variable that is assigned the character value x. And if I do print f, and these are just vertical bars that I've added in, they're not special characters or anything, they're just vertical bar characters. And then I want to have var here, and I want to align it to the right and pad to n with spaces. So I want to pad to 5 characters with spaces here. Now that is inside what we're dealing with here. So you'll notice, see those little tiny dots that my text editor is showing? That's to indicate the space characters. So we have 1, 2, 3, 4, and x is of course 5, and you'll notice that x is on the right side of that. We could also do left align and do the same thing. So here we have var colon left angle bracket and 5, and that's going to stick x on the left side, and you'll see if we add x plus these 4 spaces, we get 5 total. We can also center align it. So here we have var colon a circumflex character in 5, and you'll see that there are 2 spots on either side of the x, and the x is in the middle. Next, we're going to align and pad to n with a character. So if we want a specific character, I can put that in front of the angle bracket. So we have colon and then an underscore. You'll see that I've padded with underscores instead of spaces. Or we could use hashtags, and I have padded with hashtags instead of spaces. Or we could even use these vertical bar characters, and I have padded with vertical bars instead of spaces. And then here I've used another character, another letter, for example, A in this case, to pad around the X as well. So a lot of different options with our formatting here. A couple of miscellaneous things that we can do. If I do name equals like this, we'll get name equals Alice, if we were to print that out. If we do the exclamation point S symbol right here, what that does is gives us name equals Alice without the quotation marks. Then we can format dates and times. This is really powerful as well. We're first going to have to import date time. So we're going to do from date time, import date time. And this is a part of the standard library that you can import. We'll get the current date time. And this is just an example. It's not the actual current time, but it's the example of a time. And this is what it will return automatically without any formatting. But now we can do all kinds of stuff. So day is a D, month is an M, year is a Y, hour is a capital H, minute is a capital M, and second is a capital S. If we take a look at this, we can actually format our time. So we can say now, colon, and then %D dot, %M dot, %Y, and you'll see that it looks like this right here. So we're separating those values with a period. And then after that, you'll see I want in parentheses hour, minutes, and seconds, and you'll notice that I have separated those with a colon, and so you'll see this is the hour, this is the minute, and this is the seconds. We could also format it like this. We could say now colon %C, and what you'll see is that gives us Friday, March 22nd, so it's going to give us the day, the day of the week, the month, the date, and then the time, and then the year right after that. And that's what that C is for. We could also do now colon %capital I %P, and that will give us the 12-hour clock, and then P for PM. And we're going to get 6 right there. Now here are the complete list of what those different characters do. For example, %I is the 12-hour clock with 0 padded to decimal number, so 06 in this case, right? %P is the AM PM indicator, so on and so forth. Now we got some more examples. Here we might format a number, and you'll see I did number colon 03. And what that's going to do is when I print that out, it's going to pad to 3 total characters with zeros. So all it did was add a 0 in front of the 42. If I do pi colon dot 2f, this is going to limit us to 2 decimal places in pi. If I take a number here, in this case this is the decimal number 255, and I want to format it as a hexadecimal number, I could say hex num and then a colon, and you'll notice I did 0, 8, and then x. Let's take a look at what that will do. If I print that out, what you'll notice is it pads it to 8 total characters. So 0 is what we're going to pad with, 8 is what we're going to pad to, the length, and then x is the format that we want to put it in. So FF, if you remember your hexadecimal conversions, 255 is FF in hexadecimal. And then I padded to 8 characters long with zeros. All right, here we have 3 things. We have product, price, and quantity, and we're going to store those. There are, of course, different data types. We have a string, a float, and an integer. And then here we have total cost equals, and we have a string. And this is a good example. We have quantity and product. And then we can even do a calculation right here. So price times quantity, and then we're going to format that to 2 decimal places. And if we print that out, we get the total cost of 5 apples is $9.95. And that is format strings. There are a lot to format strings, and that was a brief introduction to the many, many, many things you can do with them. And that should get you started in the world of format strings.
Let's talk about raw strings. So raw strings in Python are going to look a little like this. So what we have is we have a string literal that's going to be prefixed with a lowercase r or an uppercase r character. And they're going to treat all of those special characters like they're not special anymore. They're going to treat them as literal characters. So things like backslashes, for example, they are used in things like regular expressions and file paths, and any string where we're going to use this sort of stuff a lot. It's a good idea to not treat them as escape characters. So the way that we can do that, is by adding this right here. So right now we see we have a lot of backslashes in this file path, and this will ultimately eventually give us this file path, which is what we want, but it's a lot of backslashes to write. We could instead use the lowercase r or the uppercase r, and you see that it turns the whole thing into a raw string, and whenever I print this out, I get this, the same file path I got up here, but it ignored all of those special characters and just treated them as raw data. So this is raw strings.
All right, we're going to talk about bytes strings now. So bytes literals are prefixed with a B or an uppercase B character. They represent sequences of bytes. They are typically represented as hexadecimal values. So they are used to store binary data such as images, audio files, or any data that is not necessarily text. And we're going to use a text example here because text is simple. So we're going to take a look at this. So here is a raw bytes literal where it is saying this is meant to be bytes data. And you'll see all of these have a little backslash in front of them and then X to indicate that they are hexadecimal values. If we take a look at this and we decode this with the decode method, then what we get is hello with a capital H. I could also just say, hey, represent hello as a bytes literal instead of how it's normally represented. If you actually want to see the bytes, it's a little bit more difficult because Python does not naturally give you the bytes in a way that's easy to read like this. So I have written a little function here that will show you the bytes and return the bytes from a particular string so that you can take a look at it that way. So bytes literals, these will be useful whenever we want to work with the bytes of data rather than the string or something like that.